Physics, I'm here with an instructional video on how to set up and make the measurements in the Law of Refraction lab. So you're going to need the piece of polar graph paper. This is basically a piece of graph paper with a protractor built into it. I like to tape the paper down. You can see here I've taped this paper to my desk just to kind of make sure that it doesn't slide around at all. You're also going to need a straight edge. I have a protractor, but your ruler will do. And you're going to need the gelatin and the laser beam. So take the gelatin and place it along the center line. And you just want to make sure that this plus sign is at the very center-ish of your dish, okay? So allow me to draw your attention to the 0 degree mark here at the bottom of the graph paper. This 0 degree line is going to be what we call the normal line. The normal line, as you know, is perpendicular to the surface, and in physics, it's how we measure the angle of the incident ray. So for example, if a ray comes in like this, we say that that's a 20 degree incidence angle. It is not a 70 degree incidence angle. And the same is true for the refraction angle on the other side. Everything is measured relative to the normal line. So the technique I want you to use here is actually slightly different than what we did in the Law of Reflection lab. In the Reflection lab, I had you scribe a line by kind of grazing it along the paper. This time, you don't want to do that because that's going to create a lot of internal reflections in the plastic gelatin mold. So rather, what we're going to do is we're going to use that grazing method to make sure that our line is along the right angle. And then we're just going to lay the beam down flat so that we have a very nicely visible laser in the gelatin. This is the refracted beam, and this is the incident beam here. Okay, so essentially, the law of refraction tells you that for an incident angle of whatever, that there's going to be a corresponding refraction angle, and we're going to measure both of those. So let's say that we're starting with a 20 degree incident angle. So I want to bring my beam in along this 20 degree line. You're welcome to use the pencil to just sort of make sure that you distinguish it so that you make sure that you're doing the right one. And you shine the beam in like this. So you know you're coming in along 20 degrees. And then you lay the beam nice and flat, and so you've got your beam in the gelatin. But here's the tricky part. The beam in the gelatin is coming out the back of the cheese box over here, and you can't really see that. So at this point, you'll see I'm going to walk around the back side of the cheese box, and I'm actually going to scribe my line from there, okay? So again, I'm going to take my beam in along the 20 degree line with my grazing method, and then I'm going to lay the beam flat. You've got to be really as precise as you can be. And then I'm going to mark it where it comes out of the cheese box like that. So let me go through that again. Graze it in along the angle. You got the nice beam in the gelatin. Mark it where it comes out like such. I'll bring it in along 30 degrees now. I'm going to graze it in along that line. I'm going to lay it flat so it's nice and visible in the cheese box. And I'm going to mark it where it comes out by looking at it like that. All right, we're going to do a 50 degree line. We'll come in along like this. Comes down into the cheese box, nice and flat. Really, really beautiful line in the gelatin. Mark it there. And so on. Here's my 70 degree. Nice and flat. Through the gelatin, mark it there. So now we're ready to connect the dots, as it were. Remove your cheese box. You've got some nice markings here for these refracted rays. And from here, it's really just a question of keeping track of what we did. So this beam refracted out like that, and it came in along the 70 degree line. Okay, that's a pretty substantial bend. If there were no gelatin there, it would have just gone straight, but it bent all the way over to there. Okay, to make that measurement, so we've got 70 degrees incidence, that refraction line looks to me, so let's see. Remember, this says 180 up here, but we're going to call that 0. So we've got 10 degrees, 20 degrees, 30 degrees and 40. I'm going to say that that's about, I'm going to extend that so that I don't have to make any guesses. Extend it out to here, that would be 41, 2, 3 and a half. We'll call it 44 degrees. So an angle, a beam that came in with the 70-degree incident angle with respect to the normal left at 44 degrees. Okay, I had another line here, I believe, coming in along the 30-degree line. I'm starting to lose my remembrance, and so this is a lesson for you to make sure you write things down. This line came in like that, and then it, instead of going straight, bent out to, sorry, I should have gone here. I'm pretty sure that was my 40-degree line. So this is my 30, and that guy goes all the way up there. So 10, 22. So the line that came in, the ray that came in at 30 degrees left at about 22 degrees. This one, apparently, this was the 50-degree line, my mistake. So this beam came in at 50, and then it exited like this. So 50 came in at, and then left at 10, 20, 30, 1, 2, 3, 4 and a half, or 35. Okay, and so on. I'm not going to, so essentially you would follow the assignment to do the data table here. I'm not going to do all of the measurements for you, but the idea would be that you have a nice incident ray and a nice corresponding refracting ray, excuse me, and then you should make sure that you keep them all sort of straight, like make sure you know which ones go where. Okay, so that's the first part of the law of the refraction lab. The second has to do with making an observation of something called a critical angle. So the critical angle is a pretty neat thing in physics, and essentially it has to do with what you expect when refraction goes the other direction. So in the first part of the lab, we took light from an air medium and we passed it into a gelatin medium, which is effectively water. So when we went from air to water, we saw that the beam, if we were to say, here's the cheese box surface and here's the normal line, we would say that the beam bent towards the normal. As it goes from fast to slow, it's going to bend towards the normal. But what happens when it bends from slow to fast? If we came in from the gelatin and it came out, we would see the light bending the other way. So I just want to show you that there is something, there's a sort of a limiting case of this, sort of a case that you might be kind of curious about. I'm just going to turn the lights off here real quick. So in order to observe the critical angle, we're going to notice that the beam starts in gelatin. I'm going to use a little bit of spray fog here to show you that indeed the beam is coming out of the gelatin into the air. But now as the beam is originating in the gelatin, you can see it's bending away from the normal when it leaves to the air. And then look at that nice reflected beam inside the gelatin. You can see that the laser is actually reflecting off of the inner surface of the cheese box, and that's over here. Okay, so watch the refracted ray. The refracted ray, the one that's out in the air, it's getting really close to being refracted along the cheese box itself. What happens if the refracted ray is bent at 90 degrees or more? Well, we call that total internal reflection. Some of the ray was getting out. Now, all of the ray is reflected back in. The angle at which that occurs is called the critical angle. Okay, the angle at which we go from some refracted ray to no refracted ray, that's called the critical angle. Any ray in the gelatin that hits that boundary greater than the critical angle will be internally reflected. Okay, that's all for now.